We can alternatively try to think of other ways to get around trying to model every single possible combination of the 2 to k possibilities for all potential models. And we talked about using stepwise procedures as one way to do that, or we could try to use this strategy of looking at the best model of each size. So we can look at what is the best model with just one predictor, two predictors, three predictors, etc., up to a certain amount. And we can use the reg subsets function in the LEAP package of R to do this. And what we're doing is, again, we're taking crime rate as our outcome and looking at all of the other potential variables in the data set crime. And we are going to set a max of 13. Now, what we can see from this is, one, EX is first chosen and it appears in every single best model. So this may be important for explaining crime rate. Second, the model with 5 variables matches the BIC's best model that we saw earlier. So that could be an indication that that might be a good model that we'd want to run because it met these 2 separate criteria. You can also note that the 6 variable model matches the stepwise that we got with the AIC. We can also use the reg subsets function to record more than just one of the single best models for each size. So we could tell it, for instance, to look at the 3 to 6 best models for each of the sizes. And this might be useful if we're deciding between models that have similar BIC models. And I don't really want to go through this plot too much, but basically it's just to say that you want to have, again, a BIC that is lower, and you will probably prioritize subset size. Now, again, what's really nice about this is that we can keep track of the best 4 models of each size up to a model with all 13 variables included. And again, the graphic becomes a little bit hard to read when you look at all the recorded models. So if you do this, I would recommend just subsetting based on the picture. Simply, though, I think what is more typical, rather than using all of these fancy different stepwise methods or subsetting methods, I just usually try to look at 2 models that I think are realistic and represent the data generating process and look at the AIC and BIC. And we can compare those directly by using the AIC function in R. So this is me just running 2 different models and then looking at the AIC. We can also do that with the BIC using a function called BIC, or we can alter the AIC by using k with log times whatever n is. So what I'd like to conclude with is that, again, I can't stress this enough, that selecting your model is an incredibly important procedure that I am not entirely sure should be left up to a stepwise deletion method or a statistic with regard to the AIC or BIC. First and foremost, you should select your model based on the theoretically relevant variables that you think contribute to the data generating process that you're interested in. Once you have those variables, these techniques can be useful for you to then try to create a more parsimonious model from there. But this should not be the first step that you take in order to just throw a bunch of variables in and see what works.